This video is on cost, revenue, and profit functions. And we'll start with an example just to make sure we know what we're talking about here. So for this example, we'll say a rental car costs $300 to rent, and an additional fee of 55 cents per mile. Find a function C of x that gives the total cost to drive X miles. You've probably seen something like this before, but in case you haven't, remember C of x is just the name of the function. It's like y equals. But if I was talking about the cost function, C of x, it's equal to, just in words, really the fixed cost, right? How much the cost is no matter what, plus what we'll call the variable cost, the part of the cost that changes. So generally speaking, you can think of most functions for cost working like this. There's a fixed cost and there's a variable cost. Now in our case, right, for C of x, right, this is the name of the function, the cost function, it's equal to, what's a fixed cost? Well, the fixed cost is $300, the amount that you're paying to rent it. Even if you don't drive anywhere, you pay $300. Plus the variable cost, well, that's 55 cents per mile, right? So if we let x equal our number of miles, we can figure out an expression for the cost to drive that many miles. In our case, 55 cents in dollars would be 0.55 times how many miles we drive? Well, we are trying to figure out the cost to drive X miles. If it was 1 mile, right, it would be 0.55 times 1. If it was 2 miles, it would be 55 cents times 2. 3 miles, 55 cents times 3. X miles, the unknown, 55 cents times our unknown. So this would give us an expression, or a function, C of x, such that I could pick any x value for miles, and I could tell you how much it would cost me to drive. So the cost function usually has to do with a fixed cost plus a variable cost. We'll do a definition here for revenue. The total revenue a business receives is given by, and for revenue I'm going to use R of x, like I used C for cost earlier. I'm going to use R for revenue. So R of x is equal to really the price per item times the number of items sold. So there's a certain price you sell the item for, the number of them you sell. If you multiply those together, that'll give you how much money you're bringing in. All right, so this is the formula for revenue. Keeping in mind that, revenue isn't profit. Revenue is how much money came in. Profit, which will be our next definition, really has to do how much you earned. So for our definition here, for the profit, a business earns. Is given by. Well, basically, we'll use them words first. Profit is equal to. Well, how do you profit? How do you make money in a business? Well, the amount of money you bring in, the revenue, subtracting off from that how much it costs you to make your product. All right, so revenue minus cost will give us profit. In terms of a function, I'll call profit P of X. It's equal to revenue, we called R of X, minus cost, which we'll call C of X. So profit is equal to revenue minus cost. So, to make a profit, to come out ahead, your revenue would have to be larger than your cost. So when you subtract those, you get a positive number. If you lose money, all right, that would mean that your costs were higher than your revenue. So revenue minus cost will give you a negative number. And negative value for your profit means you lost money. And then we have what we call the break-even point. The break-even point occurs when your profit is zero, right? So when you don't make any money or you don't lose any money. So when P of X equals 0. But keeping in mind what that means, if P of X equals 0, that means your revenue and your cost are equal. All right, so this implies R of X is equal to C of X. In other words, the revenue is equal to the cost at that point. So let's take a look at an example here, just using all of this. So in this example, we'll talk about a company sells skis. So a company sells skis. The fixed cost for production is $45,000. The variable cost for each pair of skis is $80. Right? That's $80 per pair of skis. They sell the skis at a price of $255 per pair. All right, so that's just giving you information. So we'll ask some follow-up questions to this. So first question. Find the cost function to produce X pairs of skis. Now remember, for cost, we called it C of X. And in words, remember what I said. The cost, right? The cost function is equal to your fixed costs plus your variable cost. So if I wanted to write what C of X was, well, what are our fixed costs? Well, it tells us fixed cost is $45,000, right? That's the cost no matter how many pairs I produce, right? The $45,000 might be the cost for the building, the employees you hire, all of that. Plus the variable cost. The variable cost says that it's $80, right, per pair of skis, right? So it's not just plus 80, it's 80 times the number of pair of skis you sold, or you produced, which is X. So 80 times X will be the variable cost for X pairs of skis, plus the 45,000 gives you the total cost. And this is it, it's a function. All right, you're not going to get an answer here that gives you a solid number. It's actually giving you a formula that you can use to figure out the cost for any number of pair of skis larger than 0. The next question will ask us to find R of X, the revenue function. For selling X pairs of skis. Now remember what we said to find revenue. Revenue was equal to the price per item times the number of items sold, right? We just talked about that in our definition. So for us here, R of X is equal to, what's the price per item? Well, they sell the skis at a price of, they told us, and up here the skis are selling for a price of $255 per pair. So it'd be 255. Right, so 255 times the number you're selling. Well, you're selling X, so it's 255 times X is 255X. So R of X equals 255X. That's the revenue taken in for selling X pairs of skis at $255 per pair. Next thing we'll talk about, probably can guess it, is we're going to ask you to find P of X. The profit when selling X pairs of skis. Well, remember how you find profit. Profit was equal to, remember, revenue minus costs, right? So R of X minus C of X. And we're just going to substitute in, right? So we have P of X equals, now we know what R of X is, our formula above here, so 255X minus C of X. C of X is our formula for costs that we found up here, 45,000 plus 80X. Make sure you put parentheses around this though. This negative belongs to everything after it, remember. So 45,000 plus 80X. And then to simplify this, we will distribute this negative 1 through, right? So we end up with P of X equals 255X, negative 1 times positive 45,000 is negative 45,000. Negative 1 times a positive 80X is negative 80X. And then to simplify this, we end up with P of X equals 255X minus the 80X gives us 175X, combining like terms, minus 45,000. And that's the profit when producing and selling X pairs of skis. All right, and then you could substitute X in for your pairs of skis and find a profit. So if I were to ask you, we'll just do this on the next page. I'll call this letter D. what is the profit when 3,000 pairs of skis are sold? So what that's really asking you to do is to use, right, this profit formula we just found and use 3,000 for X, the number of skis. So we're really looking for P of 3,000, right? P of X. So P of 3,000 is equal to, we had 175 times X, so it's 175 times 3,000, and then minus 45,000. And you could evaluate this individually, or if you have a calculator that displays everything on the screen, similar to one I have here, you really could just type in 175 times 3,000 and then minus 45,000, because your calculator knows the order of operations. And I get 480,000. So this is equal to 480,000. And make sure you put units on here. The units on this are what? Profit is dollars. So when they sell 3,000 pairs of skis, their profit is $480,000. And the last question, how many pairs of skis must be sold for the company to break even? Well, remember how you break even, right? To break even, it means your profit is zero. It also can mean your revenue equals your cost. So you could solve this one of two ways, either by setting the revenue equal to the cost function and solving that, or we'll do it using the profit function so I already know what it is. So I really need when P of X equals zero, right? That's what break even means. Well, what was P of X? P of X was our function that we found a little while ago, the 175X minus 45,000. So we'll have 175X minus 45,000 equals 0. And you solve this. So you want to isolate the term that has X, so I'm going to add 45,000 each side. You end up with 175X is equal to 45,000, and then you divide both sides of this by 175, divide by 175. When you divide this, 45,000 divided by 175, I end up with X equals, now it comes out to some sort of decimal, right? This is approximately, I've got 257.14, it keeps going, 285, whatever. It's not repeating, it's just going on forever. So what's that tell us? Remember what you were looking for here. You were looking for what? How many pairs of skis? Well, you can't have 257.142 something pair of skis. You have to make the entire next ski. You can't just say 257, even though you might think to round down because you see a 0.1 here. You don't round down even though the number is lower than a 5, because to actually, make a profit, or in this case break even, you want to make the entire next ski. Otherwise, if you're coming up short of that, right, if you're not making the rest of this fraction, you won't break even. You'll be at a loss. So we're going to round this up. So 258 pairs of skis must be sold to break even. So you want to make sure you round up to that next whole number. Otherwise, you'd be at a loss. So hopefully this was helpful in learning about cost, revenue, and profit functions. You'll continue to see these throughout the course, but this is just a small introduction.